Hello students, welcome to Sai Academy. How are you? Hope you all are good and doing well. Sai Academy, as you know, provide the teaching facilities for physics from intermediate level to higher level physics like BSc and MSc, and also provide the guidance and teaching classes for the competitive examination like NET, CSIR, GATE, PGT, and IIT JAM, and pre-university entrance examination, as well as civil services optional physics paper. In the 2 days video lecture, we will be talking about the lecture for the intermediate class, which will be dealing with the topic of light, which comes under the chapter ray optics and optical instruments. Students, during the video lecture, if you have any doubts and or any questions, you can interact with us through the social media platform like Instagram, Facebook, and Twitter. So you can also check our social media pages on these websites: Instagram, Facebook, Twitter, and Telegram also. So let's start the video lecture on the ray optics and optical instruments. As you know, that nature has provided the living being a beautiful eye to watch the nature and its environment. In the human being case, we are very lucky that nature has endowed the human eye, that is retina, with sensitivity to detect the electromagnetic waves, a small range of the electromagnetic spectrum. The electromagnetic radiation belonging to the region of the spectrum with wavelength of about 400 nanometer to 750 nanometer is called the light. So light, you know, is the form of energy which makes objects visible to our eye or animal eye. The branch of physics which deals with the nature of light, its sources, properties, effects, and vision is called optics. So, under ray optics, we will firstly understand what is the optics. So, optics is nothing but a branch of physics that deals with the nature of light, its sources, properties, effects, and vision. The convenience point of view, optics is further divided into two parts. First is geometrical optics, and second is physical optics. Geometrical optics is also known as ray optics. Therefore, the geometrical optics or ray ray optics treats propagation of light in terms of ray and is valid only if the wavelength of light is much lesser than the size of obstacle. So, ray optics concerns with the image formation and deals with the study of phenomena such as rectilinear propagation, laws of reflection, and refraction by geometrical methods. Physical optics is further divided into two parts: wave optics and quantum optics. Wave optics deals with the explanation of the phenomenon such as interference, diffraction, and polarization whereas quantum optics treats light as a particle, a quanta known as photon, to deal with the photoelectric effect, Raman effect, and laser, etc. Further, we'll discuss about some important properties of the light. First property is that light travels in a straight line, and the speed of light in vacuum is 2.99792458 into 10 to the power 8 meter per second, which we generally write as C is equal to 3 into 10 to the power 8 meter per second. And it is important to note that the speed of light in the vacuum is the highest speed attainable in nature. Next important feature or properties of the light is it is a form of energy which is propagated as a electromagnetic waves. That is, it doesn't require any media for its propagation, so no media for its propagation. Light is transverse in nature and hence can be polarized. Light is not deflected from electric and magnetic fields. Light is consists of electric and magnetic field vectors, and electric vector, magnetic vector, and direction of wave motion are always orthogonal to each other. That means E, B, and its propagation direction, all three are in perpendicular direction from each other. That is, if E is this, B will be this, and direction of propagation will be this. Further important point to note that is electric and magnetic field always remains in same phase. So E and B vectors in light always remain in same phase. As I told you that light travels in a straight line, that is, it follows a linear path. It is true only in the sense that the wavelength of light is very small compared to the size of the obstacles with which it encounters. Only in that situation we can tell that light travels in a straight line. Otherwise, light can also bend. The very good example is that the black hole case. If electromagnetic waves or light passes near to the black hole, it bend towards the black hole because of the high gravity curvature of the black hole. So, for the sake of the dimension of the obstacle, we are taking that light is propagating along a rectilinear path, and from path is called the ray of light, and a bundle of such rays constitutes a beam of light. As we discussed, that light is part of the electromagnetic waves spectrum. That electromagnetic wave spectrum ranges from gamma rays to radio waves. In the increasing wavelength, we can remember the sequence from gamma rays to radio waves in increasing wavelength or, or decreasing frequency as gamma, X rays, UV, infrared, microwaves, and radio waves. That is G, X, U, V, I, M, R in increasing wavelength order. So this is the technique of how to remember the different segment of the spectrum from gamma rays to radio waves. In this segment, gamma is having the lowest wavelength and radio waves are having the highest wavelength. Further, I would like to inform you regarding the properties of the light. Our eye is most sensitive to the yellow green light, that is light of wavelength from 5550 angstrom. So our eye is highly sensitive for this wavelength, and the sensitivity of our eye decreases on both sides of this wavelength. That means if we go beyond this wavelength, our eye sensitivity also decreases, and if we go before this wavelength, our eye sensitivity also decreases. So, optimum wavelength for our best eyesight is the yellow green light wavelength, that is 5550 angstrom, while photographic plate is most sensitive to the blue and least to the red. Again, the speed of light, as I told you, is maximum in the vacuum, and it is independent of the relative motion between source and observer. That is, c plus minus v is always equal to c. That is maximum velocity or speed, whatever it is in the direction, opposite or along the direction, the maximum speed will be equal to the speed of light. The optical frequencies of the light is of the order of 10 to the power 15 hertz. We can calculate this order as we know that velocity is equal to frequency into wavelength. So, for the light of maximum frequency can be given by speed of light divided by the minimum wavelength of the light. That is, if we put speed of light is equal to 3 into 10 to the 8 meter per second, and lambda minimum, that is 4 into 10 to the minus 7, that is equal to 7.5 into 10 to the power 14 hertz. This is the maximum frequency of the light can have. And similarly, we can calculate the frequency minimum, that is equal to speed of light divided by lambda max, that will be equal to 3 into 10 to the power 8 divided by lambda max, that is 7 into 10 to the power minus 7, which is equal to 4.3 into 10 to the power 14 hertz. Therefore, the optical frequency of the light is of the order of 10 to the power 15 hertz. Further, very important and interesting point I am going to introduce you about the light is that when light passes from one medium to the other medium, velocity and wavelength may change. Amplitude may also decrease or remain constant, but frequency and color of light don't change in any situation. That is, color of light is determined by its frequency. not the wavelength of the light. So, frequency is the fundamental nature of the light. For example, if red light passes from air to water, its velocity and wavelength in water will be different from that in air, but frequency and color remain the same. That is, it will again be visible as a red light. Next important properties of light is the velocity of light for all wavelength in free space, that that is vacuum, is same and equal to 3 into 10 to the power 8 meter per second. However, in a medium, the speed of light is different for different wavelengths. If you are taking the case of Babjor, then the wavelength of light corresponding to the violet length, violet light, violet color, B lambda, and corresponding to the indigo, I lambda, corresponding to the blue light, B lambda, and corresponding to the green light, G lambda, and so on up to the red light, R lambda. They all are different. The wavelength are different for these different colors in the medium, and that is because velocity is proportional to wavelength of the light. As we know that the velocity for red light is greater than the velocity for violet light, that means lambda red will be greater than the lambda violet. Therefore, we see that if therefore we see that in a given medium, greater the wavelength, greater will be the velocity of the light. This is why the sun during the sunset and sunrise visible red to the viewers on the earth, because these times sun is at the farthest distance from the viewers, and in that situation only the red light wavelength used to reach to the viewers. Further, if the velocity of light in a medium such as water or glass is same in all directions, then the medium is called the isotropic medium. However, if the velocity of light is different in different directions, then the medium is said to be anisotropic for that light. So there are two types of medium, isotropic and anisotropic, depending on the velocity of light in different directions. Students, as per the quantum optics, there is a very important point to mention, that the light is made up of discrete pockets. That pockets, also known as quanta, is called photons. So light is consisting of the photon particles, and the rest mass of the photon is zero. This is the very important facts which may be asked in the multiple type questions in different examinations. Students, this is for now about the light and its different different important physical properties. Students, if you like this video lecture and is helpful for you, then press the like button and share with your friends so that they can also learn about the lights and its different important physical properties. If you are watching for the first time, please subscribe the Sai Academy channel and press the bell icon. If you have any query, doubts, can reach to us on the social media platform like Instagram, Telegram, Facebook, and you can follow us on the social media pages. So, friends, stay tuned and thank you.